Welcome to The Explainer. Today, we're completely dismantling a stubbornly persistent myth. You know, the idea that ancient civilizations were somehow primitive, just sitting around in the dark, waiting for modern technology to arrive. Well, actually, scratch that. The truth is vastly different, and frankly, a whole lot more exciting. We are going to dig into the staggering feats of ancient engineering that literally laid the groundwork for the world we live in today. So what do steam engines, surgical clamps, and floating islands all have in common? I know, it sounds like a totally random assortment of things from completely different eras, right? But the crazy answer is that they were all engineered centuries, and sometimes millennia, before the modern era. Let's dive right into this to see exactly how ancient empires conceptualized and solved massive logistical challenges that still boggle the mind today. To really wrap our heads around the sheer scale of their problem solving, let's look at a massive number. 400,000. That is the number of kilometers of roads the Romans built to connect their sprawling empire. To put that into perspective, that's enough to circle the Earth 10 times. And get this, 80,500 kilometers of those were perfectly stone paved. They designed them by digging all the way down to bedrock, laying concrete, and then topping it off with polygonal rock slabs. These roads were so tough and weather-resistant that many were actually still usable 1,000 years after the empire fell. Moving into Section 1, powering the ancient world. I mean, moving armies and goods is one thing, but how do you run a booming, industrialized empire without electricity? We actually had a massive near miss in history here. The Romans basically had the blueprint for steam power. A brilliant guy named Hero of Alexandria designed this device called the aeoli pile. It used heat from a cauldron to push steam through tubes, spinning a ball on a pivot at an incredible 1,500 revolutions per minute. By the late 3rd century AD, they knew all the essential elements for a steam engine, but there was a catch. They lacked a cheap industrial fuel, like coal, to maintain it. Because of the sheer human labor required to constantly feed the fires, steam power stayed a theoretical novelty instead of kicking off an industrial revolution. Okay, so instead of steam, they relied heavily on water. And this perfectly highlights how ancient engineers balanced pure efficiency with practical economics. The overshot water wheel, where water drops from an aqueduct onto the buckets from above, was up to 70% more efficient. But building that overhead aqueduct? Incredibly expensive. So they often just favored the cheaper undershot wheel, which just sat right in the natural flow of a river. They absolutely nailed cost-benefit analysis, deploying those expensive overshot wheels only where they were absolutely necessary, like at massive industrial flour mills. Which brings us right to Section 2, mastering earth and water. Let's see how this foundational engineering allowed them to build lasting megastructures and feed millions of people. If you want an empire to last, well, your buildings can't fall down, right? Enter pozzolana, this incredible volcanic clay substance found near Naples. When mixed with lime, it created a mortar that could literally cure completely underwater. This ingenious material gave Roman concrete immense tensile strength. It is the exact reason why structures like the Hagia Sophia, which used a brick dust variation of this mortar for super strong joints, were able to survive centuries of brutal earthquakes and environmental stress. And they didn't just use a one-size-fits-all recipe either. Roman engineers were essentially master chemists. They adapted their concrete formulas based on local geography. If they were building near a coast, they used 2 parts sand, 1 part lime, and folded in 1 part powdered shells for the perfect consistency. But if they were inland, they tweaked the ratio to 3 parts sand and 1 part lime. This hyper-local adaptation meant their structures simply would not fail, no matter where in the empire they were built. Now, to get the massive stones for these structures, they didn't just rely on brute force. They used physics. They had this brilliant mechanical extraction method. They'd punch a line of holes into the bedrock, hammer perfectly fitted wooden wedges into those holes, and then just fill them with water. The wood would swell with such unstoppable force that it would cleanly crack the stone right along the line. Using nothing but wood and water, they carved out massive stone blocks, some weighing an astonishing 1,000 tons. This total mastery over stone paved the way for their famous waterworks. Check out this number, 1 million. 111 huge limestone aqueducts delivered over 1 million cubic meters of water into the city of Rome every single day. And that was entirely gravity-fed, using incredibly precise, slight downward slants stretching over hundreds of kilometers. They even used inverted siphons to force water uphill and crossing deep valleys. It was a level of public infrastructure that could comfortably sustain 3.5 million people, which is wild even by modern standards. But mastering earth and water wasn't just a Roman obsession. It was a global phenomenon.
While the Romans were moving water to the people, the Aztecs were moving the earth to the water. The Aztecs engineered chinampas, which are often called floating gardens, right on top of the shallow lakes of the Valley of Mexico. They created these incredibly fertile human-made islands by weaving reeds and packing them with nutrient-rich lake mud. This brilliant environmental engineering was so productive, it literally fed the massive capital city of Tenochtitlan.
All right, Section 3, the machinery of war. Maintaining these empires wasn't just about passive infrastructure. We have to look at the brutal, highly technical challenges of conquering and defending these vast territories. Out in the open, defending troops required absolute discipline, and nothing embodies this better than the famous testudo, or tortoise formation. This wasn't just guys holding shields up. This was a synchronized, interlocking architectural structure made of human beings. By perfectly aligning their shields on the front, sides, and overhead, Roman units basically became a human tank, impervious to raining projectiles during siege battles. Let's look at their devastating arsenal. Roman artillery acted a lot like ancient sniper fire and heavy bombardment. First, you had the ballista, which was basically a mounted, torsion-powered heavy crossbow used to literally pick off enemy leaders from a distance before the ground assault even started. Then you had the onager, named after a wild ass because of its violent kick, hurling huge boulders to shatter fortresses. And finally, the terrifying Helopolis, a 15-meter-tall self-propelled siege tower. But how on earth do you move a 40-ton beast like the Helopolis toward enemy walls without getting slaughtered while pushing it? Well, it was a mechanical marvel. They used an ingenious gravity-powered counterweight motor hidden inside the tower. They wrapped ropes around the wheel axles, ran them up through pulleys, and hooked them to massive 1-ton counterweights at the top. To control the speed so it didn't just crash, they'd drop a lead counterweight encapsulated in a pipe filled with seeds to create friction, or they'd use a bucket system that emptied water at the bottom and was pumped back up. I mean, it was practically an ancient automobile. This engineering prowess extended to absolute naval dominance too. They used a terrifying chemical weapon known as Greek fire. The exact recipe was such a closely guarded state secret that historians are still debating it today, but it acted like an ancient precursor to modern napalm. It would burn right on the water, stick to enemy hulls, and just absolutely devastate enemy fleets. It fundamentally changed naval warfare forever. Finally, Section 4, medicine and daily life. Let's see how ancient engineering solved the intimate, everyday problems of maintaining public health and an incredibly high standard of living. The ancients didn't just build to survive, they built to thrive. Borrowing waste disposal concepts from neighbors like the Minoans, they elevated urban living to an absolute art form. Take their famous bathhouses, the thermae. They featured passive solar heating using large windows specifically facing southwest to catch the hottest afternoon sun. They even engineered doorposts on a slight angle so gravity would automatically swing the door shut to trap all that heat inside. Combine that with flush toilets and intricate sewer systems, and you have infrastructure that actively prevented mass disease. But, of course, when things did go wrong, their medical technology was shockingly advanced. The Romans actually pioneered the very first dedicated battlefield surgery units. They were using hemostatic tourniquets and arterial surgical clamps to stop bleeding right there in the field. They were even using rudimentary versions of antiseptic surgery to clean wounds. These were life-saving practices that essentially vanished during the Middle Ages and wouldn't become popular again until the 19th century. Absolutely wild to think about. We started with the number 400,000 for their roads, and we're bringing it back here for human effort. All of these innovations required immense, highly organized human capital. It took an estimated 400,000 man-days just to build the Pantheon in Rome. And the Pantheon wasn't just a big building, it was a mathematical triumph. Its dome integrates the concept of perfect numbers into its 28 ceiling coffers, embodying a symmetry and perfection that still leaves modern architects in awe today. As we reflect on these astonishing feats, from steam concepts and self-propelling towers to underwater concrete and arterial clamps, it leaves us with a humbling realization. So much of this knowledge was lost during the turbulent eras of late antiquity, only to be painstakingly rediscovered centuries later. It forces us to ask a pretty provocative question. Given the cyclical nature of human ingenuity in history, what modern technologies that we just take for granted today might one day be forgotten, waiting in the dust for some future civilization to rediscover? Think about that the next time you look at your smartphone. Thanks so much for joining me for this explainer, and keep your curiosity alive.